Hello, I'm Mr. Hansell. I teach physics at Cocalico High School. Right now, I am going to be looking at a document on Schoology. I do have a lot of my materials that I would use in class on Schoology as well. That way, if a student would be absent for whatever reason or they misplace some documents, they can always access it on Schoology. Some of these they can type in, but to be honest, it is a little rough using equation in Microsoft Word, so I get it if we just use those as a reference and write our equations and stuff on a piece of notebook paper. I totally get that one. It makes it so much easier. Uh, so anyway, the document I'm looking at is the Physics at Cocalico. It's under the First Day folder. We see in there we have the course goals. We want to build strong critical thinking skills, problem-solving strategies, and habits of scientific thinking. That's something that basically physics, if you would be majoring that in college, it's pretty much just all problem solving. Here's a problem, solve it for us. So that's what we hope to do with the students in here. There's a series of problems, and here's some different strategies we can use to solve those. And in the process, it also helps us to develop some critical thinking skills. For our labs, we'll get to this one a little later with the key instructional methods. We tend to use more of a here's what we would like to do in the lab, and you guys should create a lab that would allow us to explore that concept. So, like I said, I'll discuss that a little more when we get to the key instructional methods a little later on in the document. We also want to build an understanding of the wonders of the physical world around us within the context of mechanics, waves, and electricity. To be honest, I think waves is one of the cooler parts of physics. Electricity is also one of my favorites, but not a fan of electricity and magnetism. That can be a little obscure, but electricity, especially dealing with electronics, is really cool as well. With the waves, we'll be looking at mechanical and electromagnetic waves, also called the EM waves. Hopefully this year we can also get to some ray diagramming, one of my favorites, with the convex lenses. But before that, we should get through a lot of the mechanics concepts, which is basic motion and forces acting on objects and everything. I think for the most part what we think of when we do think of physics. And a lot of these students will be going off to college or some kind of higher education, so we also want to encourage habits of scholarship and personal responsibility, which we hope will aid them as they continue their education outside of Cocalico High School. That's something that once they go off to college, we no longer have instructors contacting them every day telling them, hey, you're missing this, hey, you're missing that. And the same thing with parents. They can't always be on their children's case while they're away at college. So we're hoping to develop some kind of personal responsibility and scholarship to better prepare them for that. For the key instructional methods, this is something that I touched on a little earlier, the inquiry-based labs. Students will approach new topics with an inquiry focus, designing labs to investigate physical situations. And the labs often reveal relationships through quantitative data. Quantitative just means using numbers. Qualitative is more quality. Quantitative has the quantity in it, so using more numbers with quantitative. The students then use these relationships to solve related physics problems. So we usually get our equations from the labs that we do in class. And in class, we'll usually observe some kind of behavior, and then we want to graph or investigate certain things. So what we might end up doing is saying, like for the friction lab, it's like, what did you see here? As we increased the masses on top of the wooden block, what happened? And they end up doing a lab where they write their own procedures for it, and they come up at the very end of the lab, together we come up with the equation, frictional force is equal to the coefficient of friction times the normal force, because that's where we get our equations in physics. So it's really nice that that's how the students are also finding the equations, just like the scientists before them have done it. So we do like using that method. It's nice that you get the equations in the beginning from lab work rather than what some of the physics classrooms have done, which is verifying the equations through lab work. So we find it's a little more interesting for the students, and they make a better connection when we get to come up with the equations using our lab work. And with the peer discussion and analysis that's going off of the inquiry-based labs, these students will be working with each other and, of course, with the instructor in the class as we go through the lab results, helping to determine what the equations would be and what they would be potentially finding in those labs. For questioning, that's something I know a lot of students aren't a huge fan of the whole asking a question to answer a question, but that's a great way to actually tie in newer information with older information, or by them coming up with the answer, they're the one who is drawing the conclusion. They're the one who's going through that whole process, rather than just answers 5. Having the students work through that, having the students sort of muddle their way through an answer helps them to bridge that previous information to the newer information. So we do like using the question-driven discussions as well. What do you think? And then being able to discuss it as a class. For evaluation, just like with a lot of classes, they're going to be graded on tests and quizzes. We're going to be grading the labs and any kind of unit work that they might be doing, homework and such. We do sometimes have a final project depending on what the semester is looking like. The building project is usually a Rube Goldberg machine, but in the years that we would not be doing a building project, rather than the building project being 10% of the grade, they would be doing just a cumulative final exam, which rather than being 10% would now be worth 20%. For example, if this year we're not doing the building project, which I don't believe we are doing the building project this year, the cumulative final exam will be 20% of the final grade. We're going to do away with the building project for this school year, or at least this semester, I'm sorry. And then 40% of their final grade will be quarter 1, 40% will be quarter 2, and 20% of their final grade will be the cumulative final. And that one's going to be based on all the information they would have gotten from the beginning of the semester. So everything from the beginning of this semester to the end of the semester is all fair game for the final. Great way to study for the final. I will give them multiple reviews, but they can also look back at previous exams and quizzes in order to help them prepare for that final. So at the very bottom of that document, I have my email address. Feel free to contact me if you'd have any questions or concerns. If you have anything you'd like to ask, right there it is. And I will do my best to get back to you within a 24-hour period. Sometimes if I'm absent from school, I might not be able to get back to you right away, or if it's a particularly busy day, I might not be able to get it back immediately, but I do try to get back to you within a reasonable amount of time. So by all means, if you have any questions or concerns, please feel free to contact me. So I hope you have a fantastic day, and I look forward to working with the students this semester.